Alright, so now we're going to learn about the formula for the general term of a geometric sequence. And for a geometric sequence, we need the first term and we need the common ratio. Okay, so the formula is given by an equals a1 r to the n minus 1. So notice it's almost exactly like the exponential equations that we learned a couple of chapters ago. So it's like a number that represents the initial number and then the base, which is the common ratio, to the exponent. So what's different here is the exponent, instead of being x, is n minus 1, right? And the reason it's n minus 1 is that when we were looking at exponential functions, our initial value was when x was 0, and here the initial value is when n is 1, so it's like this little shift, okay? So let's see how we can use that general term. Find the 14th term of a sequence where the first term is 64 and the common ratio is r equals 1/2. Okay, so because we have a geometric sequence, right, we want the 14th term, we want a14. Okay, so that means n equals 14. The first term a1 equals 64 and the common ratio r is 1/2. So we plug it into here. So we have a14 is a1, which is 64, parentheses 1/2 to the n minus 1, to the 14 minus 1. Okay? So order of operation says you gotta do the exponential part first. So this gets done first before you multiply. Okay, so 64, 1/2 to the 13 equals. Let's see, so we have 64, 1 to the 13 is 1, 2 to the 13, 64 over 2 to the power 13 is 8192, and if I divide 64 divided by 8192, we get 1 over 128, okay? Which is also 0.0078125, right? So this is our 14th term.